All right, so I wanted to give you guys a little background information on limestone weathering. This is the phenomena that you'll be testing in the laboratory using hydrochloric acid and some calcium carbonate tablets. Limestone, interestingly, is formed with calcium and carbonate ions floating in the ocean, and they're actually taken up by ocean creatures. So let's see, so you got your calcium, that's calcium 2+, and you got your carbonate, CO3, that's carbon and oxygen there. These sea creatures use these two things together to form their shells. This is a shelled creature here. Maybe a little sea snail or something. So they take these two elements, this element and this molecule, and they build their shells with it. Over time, those creatures die, and those shells are going to sink to the bottom. So let's say here's our creature, dies off, and those shells sink to the bottom. Now, think of 100 million years of this happening, and you get a large buildup of these things, layers and layers and layers and layers of it. It gets compressed over time, and that's what forms that limestone rock, which is a sedimentary rock. So it's formed by this compaction. So here's a limestone cliff, and you can see that all of that's all limestone. And so that was formed under an ocean over millions and millions of years, sea creatures dying and sinking to the bottom. There's another good look of it here. If you've ever been to the United Kingdom, there's this famous place there called the White Cliffs of Dover, and you can see all that. That's all sea creatures over a million years of time. There's another shot of it. So you can see this weathering happening even in human-made structures. This is a statue that's a couple hundred years old. So even over a couple hundred years, you can see that the statue has weathered away. And you see it here. This is probably a couple million years worth of chemical weathering. There's some more. You can see how it's created the weathering. So this would be from slightly acidic rain and then maybe falling down into a crack somewhere and slowly wearing away the rock, creating those fissures. So here's another example of it. Let's say you've got some slightly acidic water that's running and finds a small crack, and then over a couple hundred years makes its way through and maybe finds a couple more cracks, and it stores itself in here, and then over a couple thousand, maybe 10,000 years, it makes this little cave underneath there. So that's how you get these limestone caves. This used to be a limestone cave, but what happened is the roof collapsed, and you can see the pieces from the roof down here at the bottom. This is a scientific model of this phenomena, and here you can see that where the water has created a hole in the surface and it just disappears. You got these disappearing creeks and rivers all over the world. And it falls down into some cavern and then seeps out somewhere down the mountain further as a spring. Here's a limestone cave. Here's one. This one's really cool. You can see all the stalactites, stalagmites in there. These things here, really cool. This one's actually got lights on the bottom that kind of enhances the look here. This particular cave is a very famous cave in Lebanon. So the reactions, what's happening here? All right, so let's look at reactions, what's happening. You don't need to memorize these reactions, but I want you to know in general what's happening here. So you've got this carbon dioxide that's in the atmosphere. Obviously more of it as we're burning more fossil fuels. And you have water vapor. These two react to combine and make this carbonic acid. All right, the carbonic acid, like all acids, quickly dissociates into H plus ion and CO3 ion, a carbonate ion. Now in terms of what makes an acid, it's H plus ion. So when you have this, that's the culprit that does all the damage. All right. So then you have this calcium carbonate. Now, this could be limestone. It could be shelled creatures. It could be coral. Any of these things, they're all made of calcium carbonate. And when you add that H plus ion to this, what it does is it steals the carbonate ion, this guy here, it steals that away from the calcium. So you end up with HCO3, I think it's HCO3 minus. This may not be a balanced equation, I'm not a chemist. And then you have this calcium ion out by itself. So essentially what you can see that has happened is the calcium carbonate has been broken apart. So you had this, and now it broke it up into this. That's dissolving limestone. That's carbonic acid dissolving the limestone. Okay? Significance. This reaction of limestone weathering is a very important reaction that's going on in earth science for a lot of different reasons, but a couple of them would be climate change. Now, believe it or not, this limestone weathering is responsible or has been responsible in the past for changing the climate. One example is limestone weathering or weathering of rock caused the last ice age. So this is the one that we experienced. The end of it maybe like 10,000 years ago. The start of it probably 1,000,000 years ago. But you had this tectonic uplift that exposed rock, and that would be, in this case, with the last ice age, it would be the Himalayas. So the Himalayas pushed up, exposed a bunch of rock surface area, and then the carbonic acid in the atmosphere rains down on that and then starts to dissolve away the limestone. And the carbon dioxide from the atmosphere, stuff here, gets used up in reactions with this uplifted rock, the limestone. So what happens is you remove CO2 from the atmosphere, that's a greenhouse gas, the atmosphere, the climate starts to cool down. So what happened with the last ice age is it was the weathering of the Himalayas that caused that to happen. That's the latest theory, anyway. Another big deal, this reaction in earth science, is it creates all those cool geologic features that we looked at, underground caves, all those cool rock shapes and all of that. So that's another reason we study it in earth science. And then another big issue that we're dealing with these days is this ocean acidification problem, kind of related to the climate change issue where we're burning fossil fuels, putting a lot of CO2 in the atmosphere. When that CO2 gets in the water, it forms carbonic acid, and that carbonic acid dissolves the shells, and you can see the process here, what's happening. The shells are too soft and these creatures cannot survive. So coral is disappearing and these sea creatures are finding it harder and harder to build their shells. So those are some of the reasons why this limestone weathering reaction is really important in earth science.